So welcome back, Level 1 NCEA physicists and earth scientists, continuing on with the energy external, and today looking at electrical power. So we've looked at power in mechanics, and now we're going to look at power in electrical systems. So as we've already learnt, the watt is the unit of power, and it's basically the same as the amount of energy in joules transferred per unit time, so joules per second. Okay, so 1 watt, 1 joule per second. So in electrical power, the power is equal to the current multiplied by the potential difference. So power equals current times voltage, where the power is in watts, current's in amperes, and voltage is in volts. There's the equation there. And you can see that it's the same as a watt because a current is the amount of coulombs per second and the voltage is the amount of joules per coulomb. So if you cross multiply that, you can see the coulombs cancel out and you get joules per second, which is the watt. So in terms of calculating power, if we know 2 of the 3 values, we can work out the third. So in New Zealand, the voltage for the mains electricity, that's the electricity you get from the plug, is 240 volts. So therefore, you can use the power rating, for example, a 60 watt light bulb or a 1.2 kilowatt kettle, which is shown on those appliances, and you can use those to calculate the current flowing through an appliance. Or you can rearrange the equation. If you know the current and you know the power, you can work out the voltage, and conversely, if you know the voltage and the current, you can work out the power. So in terms of calculating a power in a circuit, then you have to measure the voltage across the component you're working out the power for. So for example here, the power of the lamp. So you measure the voltage across the lamp and you multiply it by the current inside that circuit. So the power of that lamp is going to be the current of the circuit times the potential difference across the lamp, or the voltage. In terms of power in series, as you can see from the diagram, the current and the voltage are less over individual bulbs in a series circuit. Therefore, the power, the transfer of electrical energy into light energy for a bulb, for example, is less for each bulb in the series circuit, so they tend to glow dimmer than those in parallel lamps. And conversely, for those lamps in parallel, each bulb has the same voltage across it, okay, 9 volts. Also, each bulb receives electric current independently of the other. Therefore, one of the advantages of using parallel circuits for lighting is that they glow brighter than series lamps. And finally, you might be asked to calculate the energy transformed. So we already know that 1 watt is 1 joule of energy being transformed into another form of energy each second. So 1 joule of electrical energy being transformed into, say, heat energy if it's a heater, or light energy if it's a lamp, every second. So that means the change in energy is going to be the power times the time it's actually doing that transformation. Okay, so the change in energy from electrical energy into some other form of energy is in joules. Power, of course, is in watts, and time is in seconds. Okay, so you might get some questions about that.